So we left off on 74. That's all I heard.
There's one thing that's similar between calculus and physics, though. Every time I look at this, all I see is it's like a foreign language. Except here it's like letters, and calculus is like triangle shapes.
Okay. So we finished 74, and we're now going to roll on to 77. You guys are doing look so good. Chris, it's hard to do work with your head down. No, take your pencil out. So in this, jumping up here, let's start looking at 77. Alright, so number 77 reads, as a baseball is being caught, its speed goes from 30 meters per second, so I have an initial velocity, 30 meters per second, to 0 meters per second. So I have a final velocity of 0 meters per second in about 0.0050 seconds, so time is 0.0050 seconds. The mass of the baseball, mass is equal to 0.145 kilograms. Wasn't that nice of them? They went on and put that in kilograms for you. I know, they're so nice. So, that's the information. Part A. We're trying to find the baseball's acceleration. So we're looking for acceleration. In this case, this one should be a straightforward one for you. It's going to be like it was before. Because we're going to be looking, we have a final velocity, initial velocity, and time. So in this case, we can find acceleration by looking at over, there you go.
Anybody want to forge a signature?
Yeah, that's recording, right?
Hypothetically, if someone were to forge a signature, it would be appreciated. I'm not going to do it.
Okay, so acceleration is equal to the final velocity minus the initial velocity all over time. So in this case, our final velocity is 0. The initial velocity was negative 30 meters per second. Divided by time, we have 0.0050 seconds. So this will be equal to I get negative 6,000 meters per second squared. So there's A.
Bailiff application. It's
Question?
Scholarship.
Is that why you got all the letters?
Yeah. Mr. Hall wrote one of them.
Yeah, I need to do one for me, but I don't know if
Alright, so B. What are the magnitude and the direction of the force acting on it? So now we're going to try to find this force, magnitude, direction, all that stuff. So in this case, alright, here's the mitt. The baseball comes in, hits the mitt. Okay, the motion's this way. So the question here is, which way are we going to make positive, which way is negative?
down there.
We're dealing with X direction, left or right.
Left,
Yeah, left.
So left's negative. So to the left is negative. So in this case, we're trying to find the force. This works out nice because force equals mass times acceleration. Our acceleration is going to the left, which is negative. So we're kind of set up for this to give us the force as negative because the baseball comes in this way. So it wants to go this way. So to stop it, the force has to apply that way. Opposite the direction of motion to stop it. Therefore, we're looking at a mass of 0.145 kilograms. And that'll be times our acceleration, which we calculated to be 6,000 meters per second squared. And we're going to do some math here to get us negative 870 newtons. Because acceleration's negative. It's going to the left. It has to be negative.
Why did you put negative 30 meters per second?
Because if you look up here, that sign, that subtraction
Okay,
sign still is there.
So if it was going to the right, it would be positive.
I got you.
Yep.
Okay.
Other questions? Now here's a really good thought problem on C. So when you look at C, what is the magnitude and direction of the force acting on the player who caught the ball? This is where you got to think about Newton's third law. To every action, there's an equal and opposite reaction. So the magnitude of the force is the same, but the direction is different.
So it's just the opposite direction.
That's it. Which we would get
870.
Positive 870 newtons.
That's it.
That's it. The thing with that question is it's in that depth of knowledge. Okay, like you got to be able to think and process that information through. You got to be able to look at that, process that through, and know like this is what we're looking at. All right. Questions there? You guys are doing fantastic.
Not really.
All right. What I would give for one day for you to walk in here and just be in a great mood and say, Mr. Hall, I so want to do physics problems today.
Well, probably never.
All right, Dimitri.
78. So an automobile accelerates uniformly from 0, so we have an initial velocity of 0 meters per second, to a final velocity of 24 meters per second.
0.4.
24. In 6 seconds, so time 6.0 seconds. If the car has a mass, now we got a mass, to the third kilograms. What is the force accelerating? So now we're trying to find force. Now here's where everything gets really good in depth analysis. I really like this problem a lot because I'm asking you to find force. And what do you know how to calculate force? You know force is equal to mass times acceleration. Do you have a mass?
Yeah.
Do you have an acceleration?
I know how to do this.
No, but you can find it.
You can find it.
You can find it. So we, before we can do anything, must first find acceleration.
I know how to do it.
That's what we just done. Oh.
It's the thing we just did.
There's hope! Alright, walk me through. What am I going to do?
It's going to be 4 meters per second squared.
He's done that.
Okay. A equals
Right.
BF minus BO over time.
So we got that final velocity minus initial velocity all over time. So in this case, final velocity, 24 meters per second, minus the initial velocity, which is 0. So this is kind of just taken out of the equation. Divide that by 6 seconds, which gives us what?
4 meters per second squared.
If the problems were like this all the time, I'd be okay.
Yeah, this could get us excited.
Yeah.
Oh, man. All right, so 4 meters per second squared. Now we have acceleration, but that's not what the problem asked for.
That's the
The
force.
problem asked for force. So now we got to come in here, force equals mass times acceleration. We just calculated that acceleration right there. So it is equal to the mass, which is 2.0 times 10 to the third kilograms, times that acceleration, which we calculated to be 4 meters per second squared, which will give us,
8,000.
I think it is. Oh man, not bad. Yep, he's right.
Newton.
Better. Bam. Questions? How's everybody feeling?
These ones
Nauseous
are-
'cause
I like
I
those
need
top
I like
some
these
water.
ones, they're not-
The other ones are just too hard.
I've got to get you thinking. The reason these seem easier to use is because you're used to the thinking. That's where this all comes in about. Play at. Okay? Here's what I want you to do. I want you to give 79 a shot. Actually give this a shot. Don't just sit there. Actually do it. If you're just going to sit there, it's like I was saying today in chemistry. Sitting there staring at it does nothing for you. Now's the time that you can make a mistake. I'm going to walk around, look and see how things are going for you.
What page?
It is 116.
We're doing 79.
79.
Okay.
An air hockey table works by pumping air through thousands of tiny holes in a table to support light pucks. This allows the puck to move around on cushions of air with very little resistance. One of these pucks has a mass of 0.25 grams and is pushed along by a 12 Newton force for 0.9 seconds. What's the puck's acceleration? What's the puck's final velocity?